Hello, welcome to Unit 2, Lesson 5. This is Professor Blackman. Today we're going to be talking about slope and y-intercept when looking at linear equations. We're also going to be able to find the slope of a line given a graph, and given 2 points, we're going to find the slope of the line that those 2 points are on. So I have a couple of notes down here. A linear function is given as f of x equals mx plus b, or y equals mx plus b. Slope is the m that is found in y equals mx plus b. The y-intercept is 0b when also in y equals mx plus b. So that b, remember, y-intercept is a point that is on the line that is found also on the y-axis. And then we have the slope-intercept equation, which is y equals mx plus b. And we call it the slope-intercept equation because, guess what? It contains the slope and the y-intercept. So let's look at some examples. All right, so as you see, if we look right here at y equals 4x plus 5, that's y equals, and this is m, and this is b. So we can say that the slope is 4. And our b is 5, so that means the y-intercept is 0, comma 5. Is the point 5. So at the y-axis, it touches the y-axis at 0, 5. All right, so here, again, this is m, and this is b. So m is your slope, so our slope here, and pay attention to signs, is -2. And our b here is -6, so that means our y-intercept is 0, -6. Because this -6 means a plus -6. And so our y-intercept is -6. All right, so these two are pretty quick to find out when it's already in y equals mx plus b. So let's look at some different examples. All right, so as you see, neither one of these are given to us in y equals mx plus b. So we have to solve a little bit of a literal equation to get us there. If you don't remember how to do literal equations, you can watch my previous video, 1.2, and it will show you how to solve that for a specific variable. All right, so we're going to start by subtracting 2x from both sides, and that gives us -3y equals -2x plus 8, divide by -3, each term by that -3, and it gives us y equals negative divided by negative positive 2/3 x minus 8/3. And so now that we have it in slope-intercept form, we can say that the slope is equal to the m, which is 2/3, and our y-intercept is the point 0, because x is always 0, -8/3. All right, let's look at this one. All right, so we have x on the left side and y equals mx plus b is the form we want. So I'm going to just switch the left and right side and write as 3y plus 6 equals 9x. And we can do that because if a equals b, then b equals a. So you're just switching the sides. Now let's subtract 6 from both sides. And we get 3y equals 9x minus 6. Divide both sides by 3. And that will simplify to 9 divided by 3 is 3. And 6 divided by 3 is 2, so minus 2. And so now we have our slope as 3. And our y-intercept is at 0, -2, because our b here is -2. All right, let's look at another example. All right, so these are set up a little bit more challenging, but again, all we want to do is put in that y equals mx plus b format. So we need to get rid of this 3, so I'm going to subtract 3, and that gives me -1/4 y equals 2x minus 3. And now I need to get rid of this negative 1/4. So I'm going to multiply the whole thing by negative 4. All right. And so now we just multiply that and we get y equals negative 8x, and negative 4 times negative 3 would be plus 12. So now we can see that slope, and this one is negative 8, and our y-intercept is 0, 12. All right, so again, we just want to get y by itself. And so here, I need to get rid of this 4x, and I need to get rid of this 3. And so now I have 17y equals, this cancels, and 4x minus 4x is 0x. And so I don't need to write 0x. And then 7 minus 3 gives me 4. So then I get y equals 4 divided by 17. When I divide 17 for both sides. So then here I get my slope. Now I didn't write the 0x, but that 0x is still understood to be there. So my slope is 0. And my y-intercept is 0, 4 over 17. All right, let's look at another example. All right, so now we're going to figure out how to calculate slope given a graph. One visual I always like to give students is if you have a hill with a plateau on top, and this is all for m, this is plus, this is 0, this is negative, and this vertical line is undefined. And so that's just a quick reference. Think about it like walking uphill. Uphill is positive, downhill is negative, flat is like not walking on any resistance, and then you can't walk on a vertical hill, so we're going to say that's undefined. All right, so we have this slope reference right here where it gives x2 and y2 and x1 and y1, which is just saying from point 1 and point 2. And we have slope as rise over run, or change in y over change in x. So what we're going to do is we're going to build a little triangle right here, or you can build it right here. Either way, the triangle is exactly the same. So we run 2 units, and we fell 1 unit. So we can say that slope is rise over run. And we always look at this from left to right. So we ran 2 units, so that's 2. We did not rise any units, instead we fell, so that's negative 1. So that would be negative 1/2 is my slope. Also, you can look as you go over 1 unit. If I put a point right here, as you go right 1 unit, we're going down 1/2 a unit, because that's really what slope is. How much does your line change from as we increase one value of x? All right, so let's look at this one. We can clearly see that this is positive, so we're going to again create a triangle. We're going to run 3 units, and we're going to rise 1 unit. So here my slope is rise over run, which is 1 over 3. And again, if I put a point right here, you can see we go up a third a unit, up a third a unit, and up a third unit to get to this final spot. All right, let's look at another example. All right, here, we're going to draw our triangle. And again, you can draw it between any 2 points, but we run 1, 2, 3, and we rose 1. And so this also has a slope. When we look at the rise over run, as we rose 1 and we ran 3. So this is a slope of 1/3. All right, let's pick 2 points here. And so here we only run 1, and we're not rising, we're falling. So, and we're falling 1 to 2 units. So here our rise over our run, we rose none, instead we fell 2, so -2 over 1, which of course would simplify to -2. And if you look, as you move 1 unit to the right, you're falling 2 units in this fourth example here. And so that's why it has a slope of -2. All right, our next example is given 2 points. And so this is when we're going to use this part of our equation right here for slope, where it's y2 minus 1 over x2 minus x1, or y1 minus y2 over x1 minus x2. It doesn't matter which one you use, as long as the first 2 points in the equation and the last 2 are coming from the same point. So I'm going to put this right here, this first point. I'm going to make this x1, y1, and I'll make this x2, y2. And so this 6 and 9 will be my first point, and 4 and 5 would be my second point. So when we're plugging into the equation, y2 minus y1 over x2 minus x1. All that matters is that with your x1, y1 is coming from one point, and your x2, y2 are coming from another point. So always make sure you have your negatives. So from our second point, I'm going to put my 5 here and my 4 here. And for my first point, I'm going to put the 9 here and the 6 here. Also on top you have your y values, which are your, your second values in your ordered pair. And then on the bottom you're putting your x values, which are of course the first point. So we have 5 minus 9, which would simplify to -4. And we have 4 minus 6, which simplifies to -2. And negative divided by negative is positive, and we get our slope as 2. Okay, and so x1, y1, x2, y2. And so let's plug that into the equation. All right, so this is -8 and 3, and y on top, -4, and x on bottom is our 9. Okay, and so that's going to simplify to -8 minus a minus would be +4 over 3 minus 9 is -6. -8 plus 4 is a -4 over -6, which is 2/3. And that is our slope for this one. All right, that's all we have for today. Happy studying.